Welcome back to the Chain Coding Challenge, where each coder must continue what the other one started. In the last episode, Frank made it snow using fractal snowflakes. Now it's Radu's turn again. Let's see what happens.
Hi, let's see what Frank has for us this time. I knew he's gonna do something with snow, but I didn't expect this. This is awesome! I wonder how he did it. So he generates the snowflakes from this image. But I'm pretty sure that he generated this image himself, because I've seen these snowflake fractals on his channel. Then he randomly distributes them over the screen and sets the size and speed to be random as well. He updates the Y value and the angle at each frame and draws the image on the canvas using the translation and rotation tricks we've seen before. All the snowflakes are handled 60 times per second. And here you can see that he also updates the foreground and background snow. These are actually not images. They are polygons drawn with Bezier curves. Now what should I do about this now? I was eager to do something with sound, but Christmas is really soon and this tree needs to be decorated. I think I'm gonna try making a game. Let's see. First, I'm gonna make the decorations using PowerPoint. It's definitely not a designer's #1 choice, but I use it because I'm really familiar with it from making charts and other figures I need during my research. I'm now speeding up this part, but if you want me to teach you how to use PowerPoint like this, let me know in the comments. I made different types of items and a crosshair, which will follow the mouse, and I'll use it to shoot items onto the tree. And one of these items is a snowball. I'm gonna use that one differently. You'll see. I save all these images here as resources. Now let's go back to the code. I'll add a new canvas here for the game elements. I will refer to the canvas using this game canvas variable, which I initialize using this function. I also set the cursor style here to none because I don't want to see my mouse pointer when I'm playing. I want to see my crosshair instead. Speaking of the crosshair, let's make it now. It needs an image, and it's gonna be displayed at the X and Y coordinate. By default, this will be the center of the screen, but it's gonna change later. The size of the crosshair is going to be 10% of the canvas width. I also need to specify here the source to the crosshair image. Next, to make the crosshair move, I need to add some event listeners on the canvas. One for mouse down is needed to fire the items, and one for mouse move is needed to update the crosshair location. I'm updating the crosshair location with respect to the mouse, like this. This won't display the crosshair yet. We do that here inside the setInterval callback. We first clear the canvas and then draw the crosshair on every frame using the drawImage method of the canvas context. Notice here that I need to subtract half the crosshair size, otherwise the top left corner of the crosshair will be at the mouse location, and that's not what we want. Okay, now instead of seeing my mouse, I see the crosshair image I drew in PowerPoint. The crosshair is also centered at the mouse location. Next, our game will show a score. And I also wanted to display what is the next item I'm going to shoot. To show the score, I first get the canvas context and write some text on it using a white color and any preferred font. I'll put the score in the top left corner, so I'll align it to left here and set it 10 pixels from the left and 20 from the top. The score will be a global variable. To display the next item we fire, I use a similar text but align it on the right instead. I want to display the next item as an image under the text. I haven't loaded the item images yet, so I'll do that now. There are 8 types of items, so I'll use a simple for loop to initialize the image objects. Then I set the sources one by one to the names I gave to my image files. I initialize the first item to be the candy cane. It's my favorite. Okay, now we have the score on the top left. All item images are loaded in memory, and the next item to shoot is shown on the right. I'll use an array to hold all the items. When we fire, a new item will be added to this array. It will be located at the crosshair location, have a size of 150 pixels, and be shown as the image specified by the next variable. I also update the value of the next here to a new random value between 0 and 7 basically. Now we need to update all items on every frame. After an item is fired, it needs to move away from us. I'll simulate this by reducing its size, since this is a 2D canvas and I don't have a third axis to work with. When an item's size becomes 0, I remove it from the array. I also draw the items here as well, making sure I centered them by subtracting half the size in each direction. Okay, great. When I shoot, the item gets smaller and smaller until it's gone. The next item showing in the top right corner also changes as expected. Next, I want them to get stuck on the tree when hit. I'll consider all items to not be stuck initially, a simple Boolean variable. Then, when I update the items, I will pay special attention to those with a size of 50. The idea is to consider a size at which items are at the same level as the tree. Otherwise, they are in front or behind and collision detection doesn't need to be done. So, if an item's size is 50 and it hits the tree, we make it stuck and we increase the score. I need to consider only unstuck items here, otherwise the score will increase on every frame like crazy. Then I need to ignore items that are stuck. When I resize, I don't consider items that are stuck. Their size doesn't change afterwards. To do the collision detection, I use pixel values. I check to see if the canvas holding the tree has any visible pixel at this point. I specifically look at the alpha value. A value of 0 means it's transparent, but all others mean that there's something there. So it will hit and the item will get stuck on it. Okay, wow, it works. Items actually stop when I fire at the tree, and the score goes up. If I click somewhere away from the tree, nothing happens. But on the tree, they indeed get stuck. Note that when you click in some of these holes, the item actually goes through the tree. I think this is nice. It makes the game a bit more difficult and maybe more realistic. Items get stuck also on the trunk of the tree. I think it's okay, but what's not okay is this. The trunk of the tree actually exists behind the snow, and items get stuck on it. I'll fix it in this simple way. Can you tell how I solved this? Leave a comment if you think you know the answer. The game works as before, but here items don't get stuck anymore. Now the score only goes up. There's no challenge in that. I'll make a check here to see if the player is throwing the snowball. If it hits the tree, I will call this function called no. Otherwise, I keep the same logic as before. The no function is going to mark all items as falling and reset the score to 0. This is obviously something you don't want to happen. Falling items need to be animated differently here, so instead of decreasing their size, I will move them downwards by increasing their y coordinate. I remove items that are off screen. Let's see now, does this work? And the snowball. Yep, it works. No! So how should you play this? Well, you just add items to the tree and be careful when the snowball comes and discard it. There is one more thing we need to do here. Add a time limit so that we have a game over. I'll set a round duration of 20 seconds. And to start the game, I'll add a button in HTML, which will call a function called startGame. We need to define this afterwards. I will place this button somewhere at the bottom and style it in CSS slightly. But you can do much better here. This video is becoming too long and I want to wrap it up now. Okay, so in our startGame function, we set the game over to false, record the start time. You know what? The end time would be better. I'll set the end time to be the current time plus 20 seconds. I'll also empty the items, in case we played earlier, and reset the score and hide the button. I just need to update the time now. I get the remaining value like this. If it's 0, it's game over, and I show the play button again. Otherwise, I draw the remaining time as a gray bar in the bottom of the screen. Its width will stretch to the canvas width when the timer is full and gradually decrease as the time is running out. I call the update time function on every frame, if it's not game over. I think that's it. Oh, maybe I also disable firing after the game is over. Okay, let's try it out. Good, 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 good. Discard. Good, 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 good. Discard. Good, 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 good. Discard, discard. Good, discard. Good, good, discard. Okay. I got 18 over there. I think I'm happy with this, but what do you guys think? I'll leave a link to the game in the description, so try it out and let me know in the comments. Christmas is really soon and I don't think we have time for more tutorials. But let's see what Frank thinks. We may just have one more surprise in store for you. Happy holidays!